Okay, welcome to section 6.2, page 3. So you were working, I believe, on some classwork problems, and actually you'll get the answers for those when you take a look at the answers. So we're going to continue on here with example 10. So we're expressing this mixed number as an improper fraction. So I went ahead and drew some pictures to make it easier for us. So we have a whole here, so we're going to shade in the whole, and then we want 2 of the 3. So notice that we took each one of these and each one of the wholes and divided into 3 even pieces. So I could do a little bit better job here in light of trying to keep the videos short. We would count then 1, 2, 3, 4, 5. That's how many shaded pieces we have. Over 1, 2, 3. That's how many pieces the whole is divided into. So we say 5 number of shaded pieces. And that's the number of pieces one whole is divided into. Okay, so that's the way we do it with a picture. But how about if we don't want to do it that way? What if we just want to do it using arithmetic? So the way we do this is we say we take the whole and multiply it by the denominator. So we would say 1 times 3, and then we add up the numerator, okay? And that's all over the denominator. So think about, isn't that what we're doing here? We're counting a whole. Well, how many pieces are in the whole? However many is in the denominator. So 1 times 3, that gives us the 3, and then the 2 extras. So 1 times 3 is 3, plus 2 over 3, so that gives us 5/3. So either way, we get the same answer. So once again, we take the whole, multiply it by the denominator, and add the numerator. Okay, so here we want to do it in a mixed number. So basically what we're trying to figure out is how many wholes do we have? Well, that's really asking how many times does 4 go into 21? Also, this right here written as a fraction, this little fraction line means divide. So really we're saying negative 21 divided by 4. Well, let's ignore the negative and just stick it out here. We know a negative divided by a positive is a negative. So let's put the answer down here as negative. And then just go about dividing. So we're going to say, how many times does 4 go into 21? Well, it goes in 5 times with 1 left over. So our answer here would be we have 5 wholes. And think about it. Every time you take 4 out, you're going to be able to take 4 out a bunch of times. How many? 5 times. With a remainder of 1. So we write, instead of remainder 1, we say 1/4. All right, so we could draw a picture there, but they're not asking us to do that. All right, so pause the video now, try numbers 9 and 10 for your classwork, and then read the definition for the subtraction of fractions, and then come on back. Okay, so hopefully you were able to do those problems. And so now we're going to talk about subtraction of fractions. So when we subtract the fractions, if they have the same denominator, it's fine for us to keep the same denominator and just subtract the numerators. If they have different denominators, we are not able to subtract them. We have to get a common denominator, so that would be multiplying this one by d over d and this one by b over b, so that then the denominator becomes bd and we have ad minus bc in the numerator. So let's try these rules with a couple problems. So on this first one here, we're supposed to find the difference, write it in simplest form. So we see that we have a denominator of 8. Because it's the same, we can go ahead and subtract the numerator. So we would just say 9 minus 4 over 8, which is 5 over 8. And we're finished. Because these have nothing in common, the answer is 5/8. So here, we do not have the same denominator, so we need to get one. So I think we looked at this once before, 10, and we said, well, 10 doesn't work because 6 doesn't go into it. 20, does it work? We're taking the next multiple. 10 times 2 is 20. Does it work? No, because 6 does not go into 20 evenly. Okay, so let's go up and try one more. 30, 3 times 10. it works. 6 goes into 30. So we're good here. We've got our LCD. So let's go ahead and figure out what these fractions would be. So 5/6, make myself some room there. 5/6 is going to equal how many 30ths? That's what we're asking ourselves. So to get from 6 to 30, we have to multiply by 5. And whatever we do in the denominator, we have to do in the numerator. So we get a total of 25/30ths there. And then we're going to say 7/10. We need to convert it to 30ths. So how do we get from 10 to 30? Multiply by 3 over 3, so that becomes 21. So let's bring these fractions back. 5/6 is 25 over 30. Minus what's 7/10? 21 over 30. So when we subtract those, we get, now that we have the common denominator, we can subtract the numerators, leave the denominator the same. We get 4 over 30. But are we finished there? No, because they do have a factor in common. So go ahead and divide by 2, both numerator and denominator. And then what do we have? We have 2 divided by 15. Anything in common now? No. So we can go ahead and circle it and we're done. Okay, that finishes page 3. Go on to page 4.